This is the general method for drawing conics. Data required to follow this method is eccentricity and distance between directrix and focus. In this problem, you assume eccentricity as 2/3 and distance between directrix and focus is 65 mm. Eccentricity definition is something like this. It is the ratio of distance of a point from fixed point to fixed straight line. The fixed point is called as focus, fixed straight line is called as directrix. Now the first step is something like this. Draw a vertical line and name it as AB. From the midpoint of this line, draw a perpendicular to AB. This AB represents the directrix. Now the midpoint is C. From C you have to mark focus F at a distance of 65 mm. Now you have to divide this CF into some number of equal parts. That number you have to decide based on the eccentricity value. Here eccentricity is 2/3. So add numerator and denominator, then you will get 5. So you divide this CF into 5 equal parts. Something like this. Now it is divided into 5 equal parts. Now you have to locate the vertex. To locate the vertex, if you take the numerator, this numerator represents the distance of the vertex from focus. If you take the denominator, this denominator represents the distance of the vertex from directrix. So if you take numerator, you have to count for second division. If you take denominator, you just count third division from C. Now I will take the focus. That means 1 and 2. At second division I have to mark vertex. After marking vertex, you draw a perpendicular to CF passing through point P. After drawing this perpendicular, you take V as center, VF as radius, draw a semicircle. You call these points as E and K. Now you draw a line joining CE and extend it. Similarly CK and extend it. Now after V, you take some points. You have to take some number of points until you will get a closed curve. While drawing ellipse, if you are drawing a parabola and hyperbola, you can take 3 or 4 points randomly, that's enough. Now I will mark some points like this. One, 2, 3, 4, 5, 6, 7, 8 points I am taking. Now from each point, draw a perpendicular to CF like this. After drawing perpendiculars, you call these intersection points as A1, A2, A3, so on A8. Now you take 1 A1 as radius, F as center, draw an arc cutting 1 A1 line. Draw an arc like this. Top side one arc, bottom side another arc. Similarly, take 2 A2 as radius. Same F as center, draw an arc. Top one, bottom one. Similarly 3 A3 radius, F as center, draw an arc. In this way, repeat the same procedure with other points also. Now sixth point is somewhere here. If you take seventh point, that is intersecting on this CF extended line, that means that is the other vertex. That is the other vertex. Now draw a smooth curve joining all these points. Now we have drawn the ellipse. Now at a particular point P, I want to draw tangent and normal. Then how to draw that? Okay, now assume this is that point P. You want to get tangent and normal at this point, you have to draw a line joining P to F. Draw a line like this. Now after drawing the line PF, you draw a perpendicular to this PF line towards the directrix, something like this, that will intersect the directrix somewhere here. Now from this intersection point, draw a line to P that will represent the tangent. Perpendicular to that line is the normal. This is the general method for drawing conics.